Awesome. Hey, everybody. Take your time. We'll start in about 30 to 40 seconds. So grab your tea, grab your coffee. I know a few folks are still joining, trickling into the room. So yeah, take a moment. I want to say, first off, just thank you so much to those of you who joined us last month. We had a really fun discussion with Tyson and Jack on agentless versus agent-based, talking about the merits of both, when to use each one, how to use them together. So if you're interested in that agentless versus agent-based discussion, definitely encourage you to go back and watch that. It's on the website. But this month, really excited to have Craig on. It's his first time on Uptycs Live, and he's going to be bringing his expertise talking about anomaly detections. So without further ado, let's go ahead and get started. Craig, why don't you introduce yourself to everyone? Oh, it looks like you're on mute there.
So yeah, thanks for the introduction and thanks everybody for joining us. So my story is I was in one of my first jobs out of college. I was picked by a security product startup and we got the MVP and started planning detection features. And for various reasons, nobody wanted to kind of volunteer to work on the detection features. And so I thought it was interesting that we didn't know what it should do, but we could do almost anything. So I said kind of, you only live once. So I volunteered to do that. Went on to do similar things at a couple of more security product startups and worked at some bigger companies along the way. So I've basically been threat hunting detection for most of my career. In between startups, I spent some time running security and doing work on security at some of the largest AWS users here in the Boston area, which is my local geography. And so just learned a lot about cloud security there and how different it is. And got interested in that. I've done a bunch of research on cloud, basically on cloud threat hunting and detection, given a series of talks about that at some conferences over the past few years. And so continuing that work. And so what we're here to talk about is how anomaly detection can complement conventional detection in order to kind of to try to find things that sometimes are resistant to detection or hard to find in cloud API logs.
No, that's awesome. Thank you so much, Craig. And I mean, 20 plus years of experience in anomaly detections. I'm sure you've got a wild amount of war stories that you can share with us. Hopefully, we can get a couple out of you today. So I'm really excited to have that expertise on. Just to kind of give a quick overview for the viewers today, what we're going to be going through. We're going to spend a few minutes just kind of doing a roundtable discussion here with Craig. Then we're going to share a couple slides, kind of some background on some case studies that he's been working on, and then finish off with some of the upticks in action portion, showing you some of the UI itself and really how to implement anomaly detections with some best practices. And then at the end, we'll open it up to a light Q&A. So definitely, if you have any questions, drop them down below. This should take about 30 minutes, so we're really excited to get into it all. Maybe for the first section of this roundtable discussion, Craig, why don't we just start with what is an anomaly detection? Just give us this base overview of the definition and kind of how it fits into the picture of our threat hunting and detection engineering world.
So what it means in practical terms is it usually means some kind of an outlier. So a behavior or a transaction or a combination of factors or a combination of observables or field values, that combination of things that are outliers either because they're extremely rare or they're possibly new and have not manifested before, or they're extremely dense. In some cases, really large spikes in certain kinds of event data streams like errors, sometimes really large spikes in data volumes to and from particular kinds of destinations can be interesting. So it's not always, but much of it is, well, some of it is about things that are statistically sparse or dense and at the extreme opposite ends of that spectrum. And sometimes we're looking for things that are new that we just haven't seen before.
Yeah, no, that's awesome. It sounds like traditional threat hunting is much more prescriptive with writing rules. And this is a little more abstracted in a way. How do we think of them working in tandem? You don't want just threat hunting or just anomaly detection. How do we think of bridging these two worlds and 1 + 1 = 3 here?
Yeah, and so that's, part of the message is I'm not here to say throw away everything you have and just use anomaly detection. Because that's not, I don't think that that's the world where that's not where we're at today. And it may not necessarily be where we're going either, because there is no single tech detection technology that is really great at finding all kinds and classes of threats. You get much better results and much better efficacy when you use different kinds of detection technologies and tools in concert, in combination, in ways that are complementary. So anomaly detection is good at finding things that are hard to find in the haystack because they look too similar to normal innocent activity. Or sometimes it's also good at finding like what's coming next, like the next emerging threat that we need to find, but we don't know we don't know what it is yet or what it looks like yet, but we still need to kind of find it and see what's coming.
Yeah, no, that's awesome for giving the foundation piece of just what exactly is anomaly detection. I'm curious, maybe if you want to share your screen, we can start to walk through a little bit of, when we're threat hunting, what are we actually threat hunting for, and what are our tools that we can use to build out these anomaly programs?
So we have a few examples here, just a few slides, just to kind of give a quick overview. So in the cloud landscape, one of the things that you run into that you learn right away is that very often people will bring their existing security tools and technologies and standards and practices to the cloud and expect to use their existing tooling and kind of do security the way that they're used to. And it's not you can't do that. It's not that that doesn't have value. It does, because there are kind of virtual networks to monitor, and we can put EDR agents or endpoint agents or instrumentation on virtual machines and servers. But there's a whole nother there are whole other worlds to think about in the cloud, because the last time we scraped, there were 354 services in AWS the last time we counted them, and there may be more today. And those services have at least 13,000 actions that can be called. An action is basically like a command you can think of. But really only one or two of them are relevant to conventional technologies like next-gen firewalls or EDR agents or all that stuff that we're used to. And that is, the virtual machines and possibly some of the virtual container services. But as far as the rest of it is made up of pure services that we can't monitor with a firewall, an intrusion detection system, or any kind of endpoint or host-based instrumentation. So then, what does it look like? Like, what are we actually looking for is the next question. So there are a handful of examples that are out there, and there are three kind of big public record case studies that have been kind of looked at a lot. There are more than three in total, but there are three that they actually went to litigation. So there's a lot of public record detail about them. So back in 2016, in the government sector, there was a case where somebody was able to obtain credentials for a cloud user, and using those credentials was able to authenticate as that user and basically just start sharing snapshots in order to exfiltrate data. So they weren't copying data around a network or anything like that. They were actually just sharing snapshots with their account in order to kind of forklift data from the victim account to the attacker's account. And so it was a case of credentialed access and large scale exfiltration. And then in 2019,
Just to
there was
pause for a
another.
minute there, Craig. So
Yep.
what happened in that 2016 it wasn't necessarily like an abnormal action. What we would detect on is actually it's an abnormal user performing a normal action.
Yeah, exactly. Because there's nothing inherently strange or unusual about sharing snapshots, and that's true of most cloud actions, because most organizations have many accounts, and people share snapshots and lots of other things between accounts, and it's completely normal. And so at this particular time, if somebody had been scrutinizing who was sharing snapshots with which accounts, if somebody had been really scrutinizing that, then a threat hunter might have noticed this. But on any given day, there are people sharing snapshots, but there are 13,000 other actions to think about, and there may be hundreds or thousands of users. So it's really hard to try to find the few suspicious events amongst millions or billions possibly.
Yeah, that's quite the haystack.
So in 2019, there was another case that's a bit more complex, in that there was this complex attack chain, which I won't fully go into here because you can read all about this in great detail. But essentially, this was another case of credentialed access. And what's different is that they came through a web application firewall. And they were able to get code execution to interrogate something called the metadata service, which is it's just a cloud service that lets a virtual machine ask questions about itself. But you can also, if the virtual machine is authorized to do things, it can also request permission and temporary credentials in order to take actions and to work in different services. And so they're able to obtain credentials this way and use those credentials to access the simple storage service or S3 in order to start downloading bulk data. And one of the things you notice is this is another case of credentialed access. And much of the time, at least a third of the time or possibly more, we're talking about credentialed access where somebody is hijacking a legitimate user account. And these are cases where, again, these are methods that are not necessarily suspicious in and of themselves, because S3 is used by lots of users for lots of things, completely normal. But you can notice that in some of these cases, there's some breadcrumbs here in the form that they actually highlighted the fact that the web application firewall does not ordinarily invoke the list buckets command. List buckets is just a command that it does what it sounds like. It just lists S3 buckets where data is stored. So, again, very unusual for this role to do that. But given the sheer number of users and roles that were accessing S3 on that day at that time, it's another large haystack to hunt through. So last year we had a third case study, and this one is interesting because this one, as far as I can tell, this one may be the first major public case study where we have an insider threat component, where according to the information we have, at least according to what we have, there was an employee who was a legitimate employee and had legitimate access to cloud services, but he started using his access to do illegitimate things, according to the indictment. And so what happened is the user came in, logged in and worked just like any other normal day. But then a couple minutes later, and you notice it was 3 a.m. And so one of the things you might ask is, well, can we just look for people coming in at 3 a.m? And the answer is sometimes, because sometimes that has good efficacy, because some kinds of knowledge workers don't come in at 3 a.m. local time. Some of them are really just 9 to 5. But in large distributed systems, whether it's cloud or otherwise, there are SREs and there are people that are doing break fix, and they're logging in because they're on PagerDuty and they've got a 7, something is broken. And so there is a good amount of just normal people logging in to just debug and fix things, sometimes in the middle of the night, sometimes at odd hours. In the post-COVID world, people roam around and they go to different geographies and come from different time zones. And so the whole like unusual time of day and geography, it's not that it's still useful, but it's gotten muddier and it's less clear in the post-COVID world.
So with that in mind, how are we actually going to kind of detect on this? I'm curious. I'm seeing source geography, which I'm familiar more with, maybe like source IP address. I'm kind of curious, how are we differentiating between source geography, or maybe what are some of the breadcrumbs that we're actually looking for here?
Yeah, so the other thing that was different here is that the user was coming in from a VPN provider, presumably probably to try to obfuscate their location and their identity, maybe. And so that VPN provider would likely have been, it would have been in the log data, at least, the presence of that particular VPN provider was probably new, in that probably didn't have users coming in from that particular VPN provider. And depending on where that VPN provider operates, some of them operate offshore, and some of them promise they operate offshore and they won't keep any logs and they won't answer law enforcement requests. And some of them promise various things. Now, do they really do that? Well, who knows? But sometimes these will be located in geographies or other countries that don't really make sense. And so the reason we can tag the country is we, using a mapping service, we decorate CloudTrail events with the name of the source city, region, and country, and the latitude, longitude coordinates, so we can plot it on a map, so that we can reason about what geographies users are coming into and what kinds of activities coming in from different geographies, because that's kind of it's fertile ground for anomalies. And one of the other things here is that's worth noting is something else, according to this, at least according to what we have, something else that happened was the user modified some retention policies on certain logs. And then presumably the reason they did this is so that with a really short log retention, then by the time anybody looked at it the next day or a few days later, then if the log retention was very short, like a day or less, then there might not be any evidence to use to investigate. And so that's something that, log retention, log truncation, log destruction, log deactivation is something that's pretty common. Um, that is something that so in the cloud environment, modifying lifecycle retention policies for logging, so creating logs and modifying logs is not abnormal by itself. So applications and systems and worlds get spin up and torn down, and logging and all kinds of things associated with them get turned on and turned off. Most of that is done by automation, in most cases, or by a small number of users. So working in this particular service, modifying truncating the logs was probably or likely anomalous for this particular user. I mean, unless they were the one who actually created and just tore things down constantly.
No,
So
that's just to pause for a minute there. I'm curious. So in one of the first examples we talked about, it was more of a normal action by an abnormal user. Here we're looking through the haystack more for an abnormal action by a normal user. So it's kind of the flip of the two, in that sense. Would that be right?
yeah, exactly. Um, I've found better results coming from, in many cases, from combinations of fields and observables. So
Okay.
not just looking for rare values in a single field, like the name of the action of the command or the source IP or something else. And it's much more it's much more productive in my experience to look for rare combinations of, say, user and service, like a user working in a service they don't normally use, because many users, not all users, but many users kind of work in the same services every day. And so sometimes when a user starts working in a service that they haven't used before, sometimes that it could be that somebody started a new project, but it could also be due to credentialed access because their account's been taken over by someone else. Similarly, for rare activity, so rare command activity from an unusual source country that is anomalous, that's unusual, or especially if it's a country with which no business relationship or workflow exists. So the reason where anomaly detection comes in here is because when it comes to, like, if we look at these logs and start writing alert rules on these log events, if we start out with something simple like, well, can we alert on the get caller identity action? And well, we could, but the problem is that if you're familiar with, say, endpoint-based threat hunting, get caller identity is kind of analogous to the who am I command in desktop or endpoint operating systems. It basically tells you what your user context is, and it might tell you a little bit about what you can or can't do, but it will at minimum it'll tell you who you're logged in as, like what your user context is. And that is used in the CloudTrail data that I study, that action is used normally from anywhere from a few hundred to a few thousand users. And a lot of those users are going to be automation and programs, and some of them be humans. And sometimes it's hard to tell the difference. But it's really like, if we start writing alerts on that, we're going to just create too many alerts and start making people unhappy with us, and people start asking why we're alerting on this. So then if we think about the other dimension of it, so the source IP was unusual because it's coming from some VPN provider that probably hasn't been used before. Or if it has, even if it had, it's probably relatively rare that the presence of that VPN provider in the logs was probably very sparse, if it was there at all prior to this. But the problem with source IPs is if we start trying to make lists of source IPs, source IP has one of the highest cardinalities in CloudTrail logs and in logs in general. And by cardinality, I mean the number of unique source IPs in the logs. In the CloudTrail log data that I work with, there are anywhere from tens of thousands to tens of millions of unique source IPs. And it's really hard to try to make a list and reason about, well, these 900,000 source IPs are normal, but these 12 or whatever might be suspicious. It's just not feasible to try to scale that.
Yeah, no, that's
So
awesome. And I think kind of thinking of that in action, I'm kind of curious then if you want to start sharing maybe the UI a little bit, showing how we take this foundation of, okay, we're searching for these anomalies. We want to tie it into some of our traditional threat modeling as well and kind of uncover some things that traditional threat modeling might miss. You walked us through those three use cases, kind of showing, we're alerting on abnormal behaviors or abnormal users, and we really want to not just rely on one of those factors, but look at multiple dimensions on this matrix of anomalous behavior. So I'm kind of curious then, looking at this UI, like how do we extract best practices out of this? Maybe before we actually get into the best practices, I'll just pause for a moment and ask, maybe you can just kind of walk us through what you've built here so far.
sure. So this is our main dashboard where we display anomaly findings or anomaly detection results from CloudTrail data. And so what we're displaying here is, and I'll just cover it briefly. So we're displaying cases where we see the same user coming from multiple countries at the same time, which is kind of, classic credentialed access account takeover. And then we're doing the same thing for roles. And then we're looking for unusual activity, unusual command activity from an unusual source country. So an unusual command from a source country. So somebody from somewhere else where we don't have legitimate users is persisting via credentialed access. The source geography can often be anomalous. And down here, we're looking at unusual service activities for users. So in this case, there's a Paku user, which is just a security testing tool that is doing various things in order to generate data for this demo instance. And what it's done is it has tried to do just two transactions in the config service. And two transactions is a pretty small number because usually in cloud services, usually what you see is a user does lots of transactions in a service or they do few or none. So when a user context starts accessing a service they don't normally use, it's another possible way of finding credentialed access.
And
And
just
then
to pause
finally
for
down,
a moment, the new action for users and the new actor for key. I know there's no data in there, but that we talked about this earlier, where that's actually behaving correctly, where those would both be the use cases of an abnormal behavior for an actor, but because we're using the same data, there's nothing actually new or outside the normal rhythm. Would that be right? Or I'll let you explain a little better than I did.
yeah, because this is a demo system, so it doesn't have new behavior. It's basically just has automation that's doing the same thing every day. But even if we had demo data here, I have a better, more interesting example than what we would get from a demo system. So there was some research that's just been coming to light. It's kind of just been top of mind very recently, just this month, where it turns out there's a method called get federation token that's being used as a persistence mechanism, and it's being used in a way where somebody can continue to persist in an account by making a federated user even after the original user is disabled, that they can still persist with this. And it's a little complex, but it's interesting because this is something that is not, from what I can see in the data that I've studied, this is something that's not used very much. It's relatively unusual. And so this is a case where,
You can go full screen too if you want.
sure. So this is a case where we have some output from this function called new action for a user. And what it's found is that this particular user called this get federation token method for the first time. And I think these are actually two users. So once on February 1st and once on January 29th. So we found this with no threat intel, with no rules. There's nothing about this in the attack matrix at the time of this writing. This is relatively new emerging threat research, but we could still find this even back on January 29th or before the threat intel started becoming top of mind. We could still find this because even though we don't know what we're looking for, we can find it because this is something that the user simply hasn't done before. And if we dig into it, it really doesn't make a lot of sense for users to be doing this. So that's the best example I think we have so far of the new function.
Perfect. And I don't know if you want to go back to the UI for a little bit. I stopped you before we got to get to some of the fun stuff down below with the anomalous events and errors.
Mhm. So down here, what we have is these are different from new and rare. So these are looking for the top 5 largest spikes in a particular error name or a particular event name. And the reason being is sometimes if there's something volumetric happening, like if somebody has taken over an account and they're doing discovery, if they're using automation and scanning, and in order to do discovery or privilege elevation or to try to determine what kind of lateral movement they can do, or what can they get, as they cycle through that, the depending on what kind of roles and permissions they have, it's very common for them to create a huge spike in errors and exceptions, and typically authorization errors like access denied. So when that happens, a spike of that size can be extremely large relative to the normal peaks and troughs in errors and events. Those spikes often are extremely large and they kind of float to the top. So if we drill down on one like access denied, we can see the user context that's doing it. We can see some summary information about the user and which actions they're calling and which account it's going on in. And we can also, one of the things we've done here that's a little different is we have this button called Create Alert. And the idea here is that it's a little bit of different paradigm from, so the conventional approach is we have rules that act on events or alerts or anomalies, but we have rules that act on data points and turn those into alerts or detections, and those go into an alert or detection queue and into a manager with all the other alerts. And so, and it's not to say that we won't create alert rules and event rules for these, because we probably will. But the alternative approach here is that rather than just dropping a bunch of anomaly detection alerts on the user and saying, turn these on and learn to use them and tune them and adjust them as best you can, the alternative approach is you can come in and say, I don't want you to just give me a bunch of rules. You can come in here and kind of choose your own adventure and say, okay, I would like this to be an alert, but not that. And I would like this to be an alert and these to be an alert, but not those. And so you can kind of avoid you kind of avoid the having to trade alert fatigue for anomaly fatigue by just having a chance to have much more of a voice and much more of a say in what is and is not turned into an alert or a detection.
No, and that flexibility is incredible. And I think one of my favorite parts of this dashboard that you showed is actually the ability to drill down. You just kind of getting this macro view and then clicking a couple clicks later, you've entered the access denied. You're seeing specific roles, you're seeing specific actors, you're seeing the ARN number as well in the account ID. I think it's really important to be able to have that granular view and that macro view tied together seamlessly to be able to put together, okay, what are the key takeaways I need to be looking at for my environment? But if I need to investigate something quicker, I have that telemetry right there. And with that in mind, I do want to be mindful of the time. So I'm happy to take back the screen and share my screen for a little bit. Feel free to put your camera back on if you want, and I can open it up for some Q&A. So thank you everyone for joining us. If you have any questions for Craig or myself, I saw a couple come in, so let me go ahead and read that one off. Hey Craig, thank you so much for walking us through the detection engineering slides as well. What are some of the best practices you have for building out an anomaly detection program or incorporating it into traditional threat hunting? So Craig, if you want to take that one away.
Sure. So I'd say one of the best things to do is to go big right away. And that doesn't mean that you need to turn on, every detection and alert and create a whole mess of alerts for you to try to deal with on day one. What I mean is that the more data you throw at these things, the better and the smarter they'll get. So like our learning function, for example, um, are the two functions that we call new that are looking for either new actions by a user or a new role being assumed by a user, because users usually often kind of work in the same roles over and over. So what's great about those is we're not the only ones doing new, but a lot of the new detections out there, they look back for a day or maybe a few days or maybe 7 days. But trying to look back longer than that sometimes gets too expensive. So the way we're implementing this is that our new function will remember everything it has seen. It will remember all the combinations and the tuples that it has observed. Even if you only have 7 days of hot data, it'll still remember what it saw last month and last quarter. And it'll get, the longer it runs, the smarter it'll get. And so that's one way to kind of get better signal to noise out of these. The more data you can put through them, the smarter they'll get. I think the alternative alerting mechanism where you kind of get to choose your own alerts is another good alternative. So you don't necessarily have to worry about turning everything on and then getting, alert fatigue in the first day or the first week. You can be kind of just very kind of deliberate and choosy about what kinds of alerts you do and don't want to see.
No, that's fantastic. Thank you so much for answering that. And just to be mindful of everyone's time, Craig and I love talking about this stuff. He's clearly got a wealth of knowledge on this. So if you have any questions that we didn't get to either just now or over the chat, definitely drop us a line or reach out to us on the side. We love talking about this and are happy to keep going. And hopefully we'll have a couple other maybe shorter fireside chats about this stuff in the coming months or weeks as well. But before we go, Craig, I wanted to give you a moment just to kind of any final thoughts, any key takeaways for everyone before they head out?
No, I think it's just like I said, it's the message is not throw everything away and start using anomaly detection. It's more that we can correlate anomalies with conventional alerts. In some cases, anomalies can find things that are really hard to find or to describe in a conventional alert rule. And so it's really good. I think it can be very strategic for this kind of threat hunting when what we're looking for is such a matter of nuance, and also really good. We plan to apply this not just for cloud data, but we plan to apply this to other kinds of data as well, because it's another great tool in the toolbox. It's another way to kind of find what's coming next even when we don't know what we're looking for.
That's awesome. Well, thank you so much, everyone, for joining us this month. Hope you have a great rest of your day, and hopefully we'll see you around at next month's Uptycs Live. So thank you so much and have a great one.
Thanks.
You guys.